In addition to the measuring systems, you need to know how to convert between the two. Table 8.1 provides the most common conversion factors you will use in your shop or automotive tasks. Table 8.1 English to metric conversion chart to find. Equals multiple. Measuring tools. You've probably heard the adage measure twice, cut once. Measuring is one of the most important shop functions that you perform, because it is the only way to make sure that your project turns out according to plan. Measuring compares an object with variable dimensions to an object with known dimensions, called a standard. The standards that you use in shop and automotive comprise several measuring tools and instruments to ensure accuracy and precision. Figure 8.1 provides illustration of the most common of those tools, and the illustration numbers correlate to the following list. Tape measure, a commonly used general-purpose measuring tool. The tape measure is like a long, flexible ruler, spring-rolled in a metal or plastic holder. It is compact and measures both small and large distances easily. Ruler or rule, scale provides a high degree of accuracy in measuring small to medium dimensions. Rulers are flat instruments, made of wood, metal, or plastic that 1. Tape measure. Simple caliper. Are graduated into a number of spaces. Steel rules, scales, are especially useful in finish work. Most rulers are both English and metric, with the smallest gradations normally 1/64 of an inch and millimeters. Caliper, used extensively in metalworking, calipers can measure irregular shapes and thick stock. The Vernier Caliper combines a steel rule with caliper legs, and sometimes a depth gauge, and gauges the thickness of a material or object. Or measures the inside or outside diameters of holes or rods. A vernier caliper is a more precise tool than a normal caliper, gauging thicknesses to the hundredths of an inch. Micrometer provides the highest degree of precision for measuring the diameter of cylindrical objects such as bolts, shaft, or holes. Micrometers can measure inside or outside diameters, depending on the design. Outside micrometers measure the external surfaces of cylinders, screws, drill bits, and such. An inside micrometer measures the diameter of holes. Micrometers are accurate to within 1/1000th or 1/10,000th of an inch. Square, an L-shaped tool that is used to mark lines at a right angle before cutting, or to check corners and joints to verify that they are square, intersect at a 90 degrees angle. Large steel or aluminum squares are Carpenters Squares and are essential for house framing and other large construction jobs. Tri-squares have a similar design and are used in smaller woodworking or metalworking projects. Also for smaller jobs is the combination square and level, which has an adjustable square depth. Plumb Bob uses gravity as the mechanism to indicate perfectly vertical lines. The Plumb Bob is a weight that is pointed at the bottom and hung by a string so that it does not touch the ground, allowing gravity to indicate the straight path. The Plumb Bob is essential for tasks such as structure framing. Level ensures that surfaces are level, horizontal, or plumb, vertical. Levels are bars of plastic, wood, or metal with a set of marked bubbles to indicate the degree of level. Larger levels are essential tools during construction processes, such as setting fence posts and house framing, while small levels are handy for smaller projects, such as hanging pictures. Small hole gauge measures the inside of holes that are too small for an inside micrometer. To use a small hole gauge, place the tool into the hole and adjust the diameter of the gauge sphere by moving an internal wedge until the gauge fits the internal dimension. Then remove the gauge and use an outside micrometer to measure the diameter of the expanded sphere. Telescoping gauge measures holes, as a small hole gauge does, but consists of a spring-loaded piston that telescopes within a cylinder. To use a telescoping gauge, place it into the hole so that the piston can expand to the hole size. When you get the proper feel, turn the handle to lock the piston in position, remove the gauge, and then use an outside micrometer to measure across the two contacts. Feeler gauge measures the space between two surfaces, such as between contact points or a spark plug gap. A feeler gauge is a flat blade of precise, graduated thicknesses that are stamped on the gauge. To use a feeler gauge, place it in the space that you want to measure. If the gauge and the space are the same size, the gauge will feel snug as you move it in and out. Look on the gauge to see the thickness. Cutting and shaping tools. After you have measured the required dimensions, you usually need to modify your materials in some way to bring them to the correct size and shape. Cutting and shaping tools remove or separate material by ripping, cutting, slicing, abrading, scraping, rubbing or filing, and burning. We begin by looking at saws and then review shears or snips, cutting torches, planes, chisels, routers, and files. Saws. Saws cut material by digging into them with sharp teeth and removing tiny bits of material as you draw the teeth across the wood. When you begin a saw cut, you should draw the saw backwards slowly, guiding the side of the blade with your thumb to create a shallow groove, called a kerf. The kerf is the width of the saw blade, plus a little extra, because the teeth on most hand saws are slightly flared so that the saw doesn't fit too snugly in the material and get stuck. If the saw has teeth that flare only to one side, it is a flush cutting saw, designed to lie on a flat surface and cut without scratching the surface. When you have a kerf, it will help prevent the saw from slipping sideways so that you can begin the power strokes that do most of the cutting. If you are using a saw blade that is too thin for the task, you get a high degree of wobble that will make a wider kerf. Before we discuss each type of saw, you should understand its basic parts in Figure 8.2. Steel. Saw blades are described by the number of points, teeth, per inch TPI. An 8-point saw has 8 TPI, and a 12-point saw has 12 TPI. The higher the point value of a saw, the finer the cut you will get. Saws in blade design and direction of the teeth. The direction of the teeth determines the direction of the power stroke. The primary saws for cutting wood are the crosscut saw, rip saw, back saw, compass saw, and coping saw. The hacksaw is used for metal work. Figure 8.3 shows the common types of saws, and the illustration numbers correlate to the following list.